I want to open this panel by explaining to you the main point of this panel. The topic of the conference has thus far been how we can restart the feed-in tariff program, and there is a talk about 2.0. I actually would like to talk about some complementary things that can make renewable energy adoption in Ontario more feasible. And always the Achilles heel of any transition to any new paradigm is the people that make it possible. So the speakers that you will be hearing in this panel today are leading people in this planet, making the transition to training people that can do the new paradigm. So please keep in mind that the purpose of today's panel is to gather some information, and we're going to try to, as much as possible, leave room for you to comment on specific things that we should be doing or we could be doing better. And there's several people here that are members of the Sustainable Energy Initiative that will be taking notes of the key points. So as I mentioned, I prefer to start things on time, and as you can see, David Nixon is walking. He's soon going to be speaking to you. So I'm going to ask the gentleman that is managing the PowerPoints to put the first PowerPoint that provides you an overview of the Sustainable Energy Initiative of York University. And as the slide reads, what we're trying to do by uniting forces is to provide Ontarians and people from other countries with a learning experience that can actually empower them to enter this new brave world that has been created. And some of the context of these new opportunities has to do internationally with the creation of the International Renewable Energy Agency. Now there is 148 member nations that are part of this organization, and that provides a context and a potential set of opportunities for people to work on this area. Being a multicultural society and a multicultural university, we're extremely well positioned to develop relationships with the members of the International Renewable Energy Agency. The other context, which is a local context, of course, it's been discussed many times, has to do with the Green Energy Act that was created in this province. I will not discuss this because all of you are very well versed on this, but it does create an opportunity for young people to do things. And those are some slides that show who we are. We created the Sustainable Energy Initiative with partners in different areas that are very complementary to each other. So the Faculty of Environmental Studies is in our side, Kortright Center, which today is represented by David Nixon, and Centennial College, which there is Corinne. Corinne, are you here in the audience? Corinne is there and her booth is next door, so please say hello to Corinne. We also have some international partners. Next week, I'll be in Baden-Württemberg to talk to my colleagues from the Hochschule of Offenburg and also the people from Stuttgart. And there will be a speaker coming in January 25th of next year from Stuttgart that will tell people how they're doing renewable energy strategies and planning in Germany. We also have a partnership with the Nordic Folkecenter for Renewable Energy in northern Denmark. And some of the students that are here, for example, Tom, maybe you can say hello to the audience, have been this summer in Folkecenter. Sarah, I believe you've been too. Later on, a professor from Aalborg University will be joining the panel, and Professor Frede will be talking to you about the work that they're doing in this part of the world. Why does this part of the world matter? It's because it's a part of the planet where the transition for renewable energy has been made already. Denmark not only uses right now 20% of its power coming from wind, it intends to increase that percentage to 50% by the year 2020 as government policy. So people that want to understand how to integrate renewable energy can go to places like Folkecenter or Aalborg University or Samso Island to see what Ontario could look like very quickly if we implement the right strategies. And there's a photo of Tom with Ron in the Folke Center where they were about to climb some wind turbines, and they were trying some harness equipment so they could do this safely. This I like to show always because it provides some ideas. I could show you a lot of technical things, but I like this building. This is actually a building. It's a main training center of Folke Center. And you can see that's the back of the building, that's the front of the building. And Ron Offer, which is sitting there in the audience, maybe you can say hello, can tell you a little bit more because he spent the summer of 2011 in this training facility. So the things that we're interested are the things that make a jurisdiction a leader on these areas. We already have here in Ontario premiums for entrepreneurs. We can debate whether the feed-in tariff is good or bad, but we have it in place. That's an advance over jurisdictions like Michigan or anybody else in this continent. There's only a few countries in the Americas that have this in place. Now, what we need to work on more is a supportive policy infrastructure and the purpose of today's panel, which is how to develop human resources to have local capacity development. David will speak a lot about this, but just to situate where he works, he's north of here, 12 kilometers from York University is a Kortright Center, and I'm sure he'll talk a lot about the Living City campus. So instead of talking about that, I want to show you how our students interact with Kortright. So as I mentioned, we're 12 kilometers from it. So at the moment, we need to get in buses, school buses to go there. Soon there'll be a subway, soon, quote unquote, but there will be a subway that will leave us at about 2 kilometers from Kortright. And then Kortright now has, in Earth Rangers, for example, charging stations for electric vehicles. So the students could either go in their electric motorcycles or electric bicycles or electric cars in a few years and charge. They can charge today on the parking lot of Earth Rangers. Kortright offers a number of programs that are extremely interesting on how to do renewable energy installations. And we take that approach into the university, working with different professors in the university. So for example, this is a photograph of a professor from theater that worked with us on a project with electric mobility, and he allowed us to create in his shop these solar charging structures that then we could use to show the students how electric mobility can work. Because what we're trying to do here is inspire the brain of the future generations so they can think about the present in a different manner. Another project that we're involved at the moment is we're training future renewable energy leaders and working with a high school in the town of Markham. So the graduate students can teach the undergraduate students how to do solar assessments, and then they in turn can teach the high school students how to do this. So this is a solutions-oriented package, and then those people that really care about how to do renewable energy can specialize either on the programs that Kortright offers on installation of renewable energy systems, or go and do masters, PhDs, or undergraduates or postdocs on these things with our partners or ourselves. And at the end of the day, this is what we're aspiring to, is that community-level organizations, like, for example, the municipality of the town of Markham, can get on with the task at hand. But to do that, we need to create the mindset of people. Our main research areas in the Sustainable Energy Initiative have to do with renewable energy policy, the integrations of renewables, combined heat and power, district energy, smart grids, conservation and efficiency strategy, community energy planning, new communications and marketing strategies, and the education and training. I mentioned to you that this talk is part of an effort that we're doing to create a new roadmap for renewable energy. We published this one a couple of years ago, and now in turn for the new government, we're creating through these seminars, we're gathering information from experts like David, professors from Denmark, from Germany, from all countries, and people in the audience about how Ontario can move in a more strong footing towards the adoption of sustainable energy strategies. And I'm going to conclude with some of the goals that we have for 2011. One of the goals that we have is that we're hoping to enhance an existing partnership that exists with Baden-Württemberg. And next year is the anniversary of the Baden-Württemberg-Ontario agreement. And we're hoping that there will be an expansion of this agreement so people at the professional level can do secondments in institutions in Baden-Württemberg, and researchers and students can actually seamlessly go to study renewable energy in cities like Stuttgart, Offenburg, Freiburg, etc. Why? Because this is the center of the universe of the solar industry. There's a lady in the back that can speak more about the role that Freiburg is playing. Maybe you can wave to the audience. She's organizing the intersolar fairs that are all managed from Freiburg internationally, and they do work in India, in China, in California, and even here in Ontario there is a representative, to prove that a small community can actually become a world power if the right strategies for developing local capacity and human resources are taken. The second thing that we're hoping to conclude is a relationship, a formal relationship with Natural Resources Canada Red Screen. Many of you may know about Red Screen, and they will be a speaker, Charles Diarra, later on, that will talk about the work he's doing in Africa in relation to these efforts. So my last comment is this, which is present and future generations deserve a better present and a sustainable future. We inherited in this country a legacy that makes it possible for you to sit in this room today in freedom, in tranquility. We need to do better for our descendants. And I think that's the important message to keep here in mind, that this transition is necessary. It's good for everybody in Ontario, so let's get on to make it. So thank you very much. There's my contact information, and I will introduce the next speaker. It is 9:12, I say 9:15. So our next speaker is David Nixon. David is one of the most knowledgeable persons that I know in planet Earth about renewable energy. I'm not looking for a job. I can say this with all honesty, with a hand in my heart. In the 90s, I studied in Kortright how to install solar systems. And people like Alex Waters and David Nixon and some of the trainers, Sven, that are not here, will be able to really provide guidance if you're interested on anything to do with renewable energy installations. So I see our next speaker is also arrived. So I'm going to invite to the podium, being 9:14, David Nixon. Can you please give him a round of applause? Thank you very much.
I am from Kortright, which is off the northwest corner of the city. And as it turned out today, half of Viva Transit is on strike, and I didn't know which half, and it turned out I was on the half that was on strike. So I had to catch a Brampton bus to a TTC bus to a TTC subway to here. So it's interesting sometimes, interesting adventures on public transit. It only took 2 hours. It's a 20-minute drive. So there is some reason why we still drive cars, but when I'm coming down here, especially to an event like this, I think I don't feel too good unless I take the take transit. I must admit, to the last thing I came to for Jose, I only came down to York Region, and I had to like drive halfway to catch a bus, and it just seems you know, as much as we try and as much as we think we're getting somewhere, it really does drive home how far we need to go yet. Are we ready? Okay. I'm sorry, my apologies to the AV guy. I brought a different slide set than the one I had sent before. So where I'm from, we call it the Living City Campus these days. We used to just call it Kortright. I've been involved with workshops at Kortright for about 20 years now. And as it's grown and other organizations such as Earth Rangers have moved on to the property, we're now considering it more of a campus, a place where we hope that various organizations can come and work together. We have a couple of the first LEED Platinum homes there, Earth Rangers. was as lead gold, working on a retrofit to platinum. Our visitor center, which is 70s vintage, is on its way to a lead gold renovation. So there's quite a, even though we're kind of in the middle of nowhere, it is becoming quite a hub for renewable energy. What we mostly do is we have about 85,000 children a year coming to Kortright, and most of those get an ecological education. But we do have a heavy energy theme that has been there since the early 80s. Rob McMonagle, who is down here, knows when were you first involved with education at Kortright, Rob? 84, 85. So that's the kind of lineage we have. And what that brings, I think, is a lot of experience to know, lessons learned, and all the various issues that we're involved in is education, general public. And when I started there, and when Rob was doing workshops, that's who we had coming. We had cottage owners who were interested in PV for their cottage. And then slowly we found a few electricians showing up. Then we started seeing a few engineers showing up. And at some point, I had a class hold up their hands, and I said, well, who's here for grid tie? And it was like 3/4 of the class, and I kind of went, whoa, I guess we need to change our perspective. Given that, a couple of years ago, our primary objective was homeowners and educating consumers what this stuff was about, what it could do, and then we did get the odd trade professional coming in. The sites that are up there is the Sustainable Technologies. That's the program I work for. You can look to that site. We're just got about 5 case studies ready to go up there. These are various City of Toronto facilities that have photovoltaics on them. Some of them are pool systems, some of them are solar walls, and you can see lessons learned, what the actual cost of installation was, what the actual yield was, issues, say, with instrumentation, issues, say, with integration with building automation systems. There's a lot of lessons learned there. The Solar City Partnership is the City of Toronto, the TRCA, and the Toronto Atmospheric Fund. We're trying to create a network of specialization within the GTA area. There are specific performance variables to know about the GTA. We're starting a solar resource network, so you will be able to click onto that site and get what the solar installation data for that month. So current, verified, high quality instrumentation used on that. The Sustainable House is the picture you see to the right there. You can come up for tours of that. It's basically everything that you could, every energy conservation technology and renewable energy technology that you can throw at a house, as well as green building materials. So it was supposed to be a semi-detached. It was supposed to be a LEED gold and a LEED platinum house. What we ended up was kind of a LEED platinum and a LEED platinum plus, if there was such a thing. The Kortright.org, you can go there to see what our education programming is about. And then the PV is our latest undertaking, and that's where we're taking Ontario-made modules, putting them side by side, and doing performance verification. Because if you know about PV modules, just because you've got a kilowatt of standard test condition rated PV modules, 1 kilowatt of one brand does not equal the same yield as a kilowatt of another. So that's one of the things that we need to know. And we also need to know, get some good confidence, some bankability in Ontario-made modules. That's kind of our main thrust to it. There's a lot of new players in the Ontario PV market. We want to put them up, show that they work, so that the bankers can have third-party verification as to the performance of these new products. The people that work there, that's myself first. We're putting up a 100-foot 5K wind turbine at Kortright. Alex Waters, my boss, putting up Canada's first roof integrated shingle roof. Swen de Bruin with the orange hard hat on there, that's putting up his own 10K Bergie. And at the bottom, that's his own 10K tracker. I only have 3.2K, so on the PV side, I'm a bit shy, but I got a solar hot water system. So. But that's who we are. The instructors there are people who install equipment. So just a little interest, how many people in the room have installed a solar hot water system on their own home? So we have 2 of us. And photovoltaics on your own roof. Right, 5 maybe. And say put up a 100-foot wind turbine tower. Okay, yay, Rob. A few in his case. So that's kind of where we're at though, right? You know, a lot of people are interested in education and not a lot of people with a lot of hands-on experience. There's a certain number of textbooks that we get from Germany and other places to try and educate ourselves, but when we're turning around and trying to educate students, there aren't a lot of people around who have the deep knowledge of installing systems. So how long have we been around? Well, in 1982, we installed the building that you can see there. How's it doing? Well, over the last few years, you can see what that system has done. The NRC rating on those modules when they were put in 1982 was 31 watts. We tested them. They're now 29.7 watts. An overall decrease per year of 0.22 watts. So those are the kind, because we have that kind of information on the long term, that helps when we're teaching about modeling systems. We know what real degradation looks like. We know what real yields look like. As I said, our primary audience has been the general public. So, you know, that's kind of a group on the top right there, but now we've been having interaction with groups. Jose brings his students down, and even though they are not the people who are going to install systems, they're learning about designing them and modeling them and stuff, and they get to come to Kortright, see real systems working, and quite a variety of them, and they get to do hands-on. We have benchtop hands-on workshops, we have rooftop hands-on installations. We also do we then have moved into corporate training for companies like Canadian Solar. They now bring their installers to Kortright for installation training. Well, then the Green Energy Act came along, and of course, I think the interesting thing here is there's 42,000 applications and 8,000 have gone in. So we've got, you know, rough numbers, another 40,000 to install. So we need a few qualified installers. What is the environment that those installers are coming out of? And this is here to say, okay, well, if it's going to be installed, this is from the Electrical Safety Authority. This is what they charge you to have a system inspected. $260 if it's done by a licensed electrical contractor. If you're a homeowner, it's going to cost you $416. The third one is the interesting option, I think, is where an electrical contractor is going to do the AC side. They're going to put in the second meter base and put in the inverter, so essentially the AC wiring, but they do leave it open. Most people think that electricity, well, it's a restricted trade. For photovoltaics, DC side of photovoltaics, it is not. Okay, so we've kind of got a wide open, anybody can install the DC side of a PV array if they get paid $260 for the license fee to do it. So where we had moved from everybody who's installing electrical PV systems is an licensed electrician, at least they have some knowledge of electricity. Now we've kind of got a little bit more of a Wild West situation going on. So that, to me, means that we need a whole bunch of educational facilities stepping up to the plate and providing that. What I have seen is a lot of community colleges, and I'm on advisory committees and stuff, so I know what they're doing. And I see a lot of colleges providing what they tend to call front-end training. So the sales and marketing and design staff for the renewable energy industry. They're a little light, not to say it isn't happening, but they're a little light on the installer side of it. Why? Because installer side, you have to have equipment, it takes hardware. Hardware means money, and I'm glad to see that there is some money now flowing from the Ministry of Education into the colleges to help them buy this equipment, but that is the struggle that they have. So they really need help from industry to help them get the right gear in front of the right students to do the right kind of work. Instructors, if you have an instructor who is good, knowledgeable in photovoltaics, the industry wants them. So that's a bit of a challenge for colleges, is that they basically have to find someone within their organization who's not going somewhere else, who, you know, electrical or something background. But there's the next challenge, is that if your college is already training electricians, those instructors are already in high demand. Those courses are already filled to the max. We have a shortage, you know, in electrical training. So now you want to pull some of those staff off and start, you know, doing PV training. So there's another challenge for schools to find the right people. They're doing it, but with the explosive increase of this, it's a challenge. The curriculum, it's coming along now. I think a year ago I was really nervous. 2 years ago I was helping write the curriculum for the ACCC, you know, which of course has trickled down through to the colleges. They're using it. And that part of it I think we can work out. But when it comes down to installation, an installation on an asphalt shingle roof in Ontario is different than on a slate roof or a tile roof in Europe. There's just some mechanical differences. And I'm not sure where we're getting that knowledge into the curriculum. The other thing that the colleges are going to have to deal with, and Babs is going to, you know, they're a leader in this area at St. Lawrence, is that this stuff is moving fast. I can say I just got bit 2 days ago by an inverter that I didn't know that it wasn't going to isolate the different channels. I was used to microinverters isolating the DC side from inverter to inverter. We put in a new one, and what do you know? No isolation. So that's maybe gobbledygook, but it means that even someone who's right in it, things are changing so fast that, you know, I still get surprised. And you know, we were really kind of like, oh, really? No isolation. Isn't that interesting? How does the code handle that? Code doesn't know about it. So I just run down here some selected skills required for a solar PV install. There's the electrical side. Well, guess what? These systems, if you want to know they're working, your electrician has to know about instrumentation. And that means connecting to the internet and web pages and all that. So maybe you sub that part out. They also need to be a steeplejack. Not all electricians are used to handling large chunks of glass on a 45-degree steel roof. Great, thank you. So there's a bit of the steeplejack trade in there. Assembly. The racking, which is probably the thing you spend the most time on the roof with, is a mechanical assembly, has to be laid out. The connection points have to hit the rafters. You have to hit the rafters not all nice in a row, so all your point loads are on one rafter. You've got to stagger everything, which is a little counterintuitive. I've seen rack after rack where they run all the point connections up in a nice straight line. If you've got trusses underneath there, that means you're putting loading on this truss, that truss, and you're missing the two trusses in between. So yes, the roof can hold up that much weight, but when you do point loading, so it's just to say we have to follow the mechanical or structural engineers' drawings. Electricians aren't always used to doing that. So here's where we start, you know, skewing the trade a bit. You got to make roof penetrations, and they need proper flashing. That doesn't sound a lot like an electrician. Somebody's teaching that. And I think that's where our community college system is really in good state, especially some of them where they've already teaching some of these other things. So they just need to pull this together. Framing, well, unfortunately, most, especially truss roofs, they're not meant for any extra load. You got to get in there and start reinforcing the roof. In residential, it may be the guy installing the PV. In commercial, well, you're going to get a structural contractor to go in there and do the bracing, like we found out, say, at 9 Hannah. It looked like a very strong building. It already had a superstructure above the roof, but guess what? It needed to be strengthened up a bit. And then millwright. You got to, if you're doing trackers, a 10K tracker is not a small, light thing. We're talking large elements that really you need the skills of a millwright. Now, maybe you don't have your electrician doing that, but you should at least recognize that there's some skills that you need in your crew. One of my biggest concerns is this perfect storm of what I see safety issues. We've got our regular construction site safety issues, so they're in the top there. But then there's some ones unique to PV, is as soon as a module is out of the box, it's live. And it needs to be treated with respect at that point. As soon as, electricians are used to, if you have a ground fault, the ground fault interrupter interrupts the fault and de-energizes it. That does not happen with PV arrays. They may see that the inverter has gone into a ground fault situation, which I just found at a fire hall. I went to do an inspection at a fire hall to see why the yields were low. It was a ground fault. Just because the inverter's tripped and shows a ground fault, the ground fault is still energized. That's just the way these systems work. So there's some specialized training that the technicians who are going to go and service this stuff need. The other thing is that fuses don't open overloads. A fuse in a PV array, at the operating current and the short circuit current of a PV array are almost the same, so fuses don't clear faults. And then what's worse, if you go and throw one array string in beside a bunch of other strings, the fuses don't have the withstand voltage to stop arcing. So they open, but they continue to arc across the fuse. And I'll show you an example of that in a minute. So what our result there is we now have a 5-day professional training workshop. One thing we've done is we've built our roofs on the ground so that we don't have to deal with all the working at heights issues while we're doing the installation. But just to show that that is part of it, we also give a half day in fall arrest training, because that is where you're working on the roof. We cover theory, site assessment. Part of what feeds into the site assessment, of course, is we know how much modules yield in our area. So we've got a lot of input. So we don't just put, wiggle factors. If you go into ret screen, there'll be a 5% default for dirt and so on your PV array. You need to put 15% in there because ret screen's default is for an area with no snow. So you have to at least throw. So we have those information. We know what the answer is, what the yield of an array is. So you just have to make sure you put the defaults into whatever model you're using to get the right answer. And since we do the research on site, we get the numbers so we can instruct people what are the correct numbers. Part of that comes out of PV. So here you have various Ontario manufacturers side by side, and the really funny polka dot ones, those we're actually putting some of our 28-year-old modules in there to duke it out with the brand new ones. Another one of our studies is an angle study, and just to show you what a little bit of snow can do. So you can see the different angles of the modules. On the far side is the horizontal. We've got every 10-degree increment going across there. And the little bit of snow that's on those bottom right modules, you can see there's our data logging system showing 20 and 24 watts from that much snow on a module. And the one next to it, which is just another 10 degrees steeper, is of course actually producing something. We have 5 video cams watching this. So what we do is we have instrumentation on every one of those modules, and as we have our timestamps all dated so that we can compare the power output to the snow shading on the modules, and we can quantify what this is doing. What has been interesting in this, I think it stops right about there somewhere, is that the pole mount, we did all our angles on pole mounts. You can see that a roof mount behind, back right corner there, is still covered in snow, where the pole mount on the same angle is entirely clear of snow. So there, we got some more studies to do. If you don't think this is a serious business and getting your polarity on your modules right, this is what the top of a store in the GTA looks like when they had a little bit of a fault. It doesn't know when to stop, right? The fuses don't clear it. Overloads, and if they do try and clear and it's a reverse polarity situation, the voltage across the fuse is higher than what the fuse is rated for, and it just keeps arcing across the fuse until something lets go. So that was in the past year. So yeah, there are now 4 thermal events, as they are called by the Electrical Safety Authority, have happened in the GTA that are recorded, and I know of a couple more. So I don't know how I did. How did I do? Oh, 21 minutes. Sorry about that. You gave me an extra minute, so I took it.
Thank you so much. Put it here. I'm gonna just Thanks, David. This proves what the premier of this province asked on the speech of the throne of 2010. He asked that we that are involved in the education systems of this province do world-class efforts to make them of world-class quality. So you have heard now, David, and I think without a doubt, the work that they're doing in Kortright is world-class. So what I wanted to ask you is I wanted to basically give you an idea of how we're hoping to collect your thoughts and questions. There is a few people here in the audience that are members of the Sustainable Energy Initiative. So we got Ron over there. Can you say hi to people? Like, hi, Ron, so people can see you. And we have Tom and Sarah here. So can you say hello to folks? And if you have questions, please write them in a piece of paper and give them to either Ron, Sarah, or Tom, so we can make sure that your answers get provided during this panel. This panel will have a break in between. There's a coffee break, and then we will provide you with the perspectives from an international perspective and also from a college that it's also a world-class college. So the next speaker will provide you with some perspective of the work that they're doing in their university in northern Denmark. But before I introduce him, what I want to ask you is the type of questions that we are hoping to elicit answers from. At the beginning of the panel, I mentioned to you that there is a context for these questions. Our premier will be creating the speech of the throne this week. So it would be good to have some useful ideas for the speech of the throne. We are a democracy, so it's good to feed ideas to the people that represent us. And there's also the budget of 2012 coming, that it's also important to have some specific ideas on how the Ontario budget could enable the work of training, capacity development, which is essential for policy development. So the type of questions I formulated too while I was listening to David is, how can we ensure that the work that Kortright is doing, or for that matter, the work that the Energy House is doing in St. Lawrence College, or Folkecenter in Denmark, can be replicated in other local jurisdictions? Because these are jewels that are only very scarce jewels. And in my personal opinion, we should have more of these sustainability centers in different communities, both in Ontario and in other places. So that's one question that we can collectively answer. And also, what type of support can the private sector provide and the governments provide so the work of Kortright Center, the Energy House in St. Lawrence College, or Folkecenter in Denmark, or the University of Aalborg, or York University can be enhanced? So that's the type of questions that we're looking for. So please remember our representatives that are in the floor and provide paper for them. So our next speaker is coming all the way from Denmark to provide you an idea of the very good quality work that they're doing in that part of the world. I think history books of the 21st century will remain written saying that the Danish people provided a transition for the entire planet on how to do things differently. Denmark is in the forefront of the transition to a sustainable energy economy. And Professor Frede Hvelplund will be telling you how they are tackling education and training in their corner of the world, and how people from Ontario or other countries could come to this part of the world to work with knowers, doers, and experts to be able to bring that knowledge back to their local communities. So I think it's more appropriate to clap before than after. So let's give him a round of applause if you can indulge. Thank you very much.
Yes, thank you very much. I was flying the first part of the trip and walking the last part of the trip, the last 4 kilometers. So that's why I was sweating when I was coming. Toronto is bigger than I thought. So it's necessary public transportation sometimes also. And thank you also for the invitation, and also for the interesting partnership we have with York University. I'm looking forward to it. And I will make a rather short presentation, but nevertheless maybe too long, because you should just, Jose, say when it's 12 minutes or something like this.
Sarah will.
You'll do it, okay. So this is Denmark standing on Germany. You cannot see Germany, but we have a small department in Copenhagen and a bigger department, university in Aalborg, with a subsidiary in Copenhagen. And all the yellow spots are wind turbines. And the university is not big compared to your university. We have 15,000 students, full-time students. And 1,000 in Copenhagen. We are trying to conquer Copenhagen. And the goals of we just got a new government, and I think it's good to mention the goals of this government, which is 40% carbon dioxide reduction seen in relation to 1990. And it should be this 40% in 2020. And from the present 22% wind power out of electricity consumption, they go for 50% in 2020. So that, and 50% reduction in heat use per square meter before 2050, and 100% renewable energy in 2050 when people, and it's not that far away, it's when people born today are 38 years old, and I suppose that I don't know what the average age is here, but if you were born in an oil economy, then it would be 100% renewable energy just 38 years later. So it's a group of rather young people who meets this 100% renewable energy. And energy, and 2050 is now, in fact, because you have to prepare, start it now. You cannot sit until 2049 and say, okay, we have promised 100% renewable, now we have to do something. Renovation of building starts tomorrow. And also developing of new technologies takes time, if you need it. And when you don't need it, improvement takes time. And replacement takes time. So it starts now. Any decision taken tomorrow has to be seen in connection to this goal of 2050. And that's the section where I work, the Energy Planning Research Group. And I will not talk about all the people, but it's a mixture of some people working with economy and sociology, and the most people working with energy system analysis. There are two Chinese PhD fellows. We don't like to call them students, because PhD should have a real research project. So they are PhD fellows, and they work with Lixuan, the left one, works with offshore in China, and Wen at the bottom works with onshore in China. And then I'll not say much about it. Then there's Anna Wright. She at the right part of the figure. She comes from Minnesota and studies how to make a transition to a very big proportion of renewable energy in Minnesota in her PhD. And we have been doing these things for many, many years. We made an alternative energy, I was making together with others an alternative energy plan in 1976, the blue one at the bottom. And then later, there's one more in 83 and 90, 95. And we just finished a big energy plan, which in fact is written in English, and with 100% renewable energy in 2050, where we describe all the technologies in detail, and where we also describe which type of policy measure one should adopt in order to make this happen. So if anybody of you, you can see my email on the first slide. then you can just send an email, and I think in a few days after I'm returning, I can mail these reports to you. So our research goal is 100% renewable energy. And one thing is how to establish and coordinate renewable energy and energy conservation. It's very important that you make energy conservation so that you don't build too big supply system. So it has to be synchronized. And that's an interesting and a rather difficult task. And the second task, how to integrate 50% and later 100% wind in the system. That's also a task, an interesting task. Already now, when we have a lot of wind and low consumption, we have a little bit more than 100% wind in electricity. And if we double it, then we would have 200% sometimes. And therefore we have to do something to integrate it. And I will just say very quickly what this means, because I don't have much time and I'm not a technician, so it's good that I have to say it quickly, because I don't know a lot of details on it. I just know the main thing, but my colleague, that's what they are working with. You have the demand, the yellow is the demand side, and then you have, this was in 1990, you have some big power plants. It doesn't matter that you don't have any integration, because there was not much to integrate, 2-3% wind power in 1990. Then when you have more wind power, as we have had already in 2000, we started to integrate wind by means of fast reacting district heating systems. So that when the wind is not blowing, you don't produce so much electricity, you can regulate very quickly. And that's a yellow one on the right side. That's where we are to some extent now. And then we also are here now, we need to integrate heat pumps also in order to, when you have a lot of wind, you have to sell the wind to the heat market, which we don't do now. And this is very efficient to do this when we have a district heating system and heat pumps. So as soon as you have too much wind, you can just sell it to the district heating companies and produce it very efficiently by using heat pumps. And that's the first step of, you could say, of advanced integration. But this makes it possible to have around 50% wind power just to do this, because the heat market is eating, you could say, all the peaks. So you can just cut them away by means of the heat market. So you don't need the electric storage system at that stage. And later on, when the wind is around 2020, is big, as you can see on the blue box down the bottom, then you still need heat pump, you still need CHPs and district heating, and then you also can integrate electric cars to some extent. And this, and then you can continue. We are working with also syngas, combine biomass and wind, and make gas out of it. That's it. And these systems, this is not only something that we suggest at the university. It's something that our grid company is doing, is researching and planning also, and they also accept and think it's possible to have 50% wind power in 2020. So this is not a question discussed, it's something that officially is accepted as a possibility in 2020, when people born today are 8 years old. So this is typically for, okay, just go down. This is one leg we are walking on. We need 2 legs. So this is the first leg. We have the system engineers studying how to integrate wind and also solar power and also wave power later on a little bit in the system. And it's this big integration task that is our speciality, and that is, you could say, also the Danish coming speciality. And it's a necessity. If we don't do this, then wind has no value, because we have to export it. And other people having much wind also have to export it, and the price will be extremely low. So you have to integrate wind with transportation and heat. And that's our main message also. And that's what we are studying. And we have a simulation program which hour for hour tries to simulate this situation. Then we have the other leg. We also have to find out how can we implement this. So we have to study what hampers and what supports. Usually I'm only studied what hampers. That's a negative attitude. I also have to look at the open doors, and there also are open doors and has been open doors. The development and implementation. And we also have to find out which policies should be implemented in order to remove these hindrances, if there are hindrances, and there are hindrances. And then I will just show a few figures which I was doubting whether it was a good idea, but I'm taking them anyhow. This is how we see economy. At the top you have the market, this white cross up the top, and we see economy as, you could say the market is a plant growing in some tax structure, tariff structure, what the schools are learning, and which technological institutions there are, and who owns the. So it's like in a garden. The soil can be good or it can be bad for a given technology, and the market is just a human construction where you have made the soil in a specific way in Denmark and another way in Canada and so on, and you have to analyze this soil in order to find out what should be changed. And the first step is, it's also a political thing, because the old system and the old way the system was working, it was you only have influence from the fossil fuel companies on the market, and then you got some. We have carbon dioxide quotas which were made in such a way that they were supporting the big old companies. And you also have certificate trading which was supporting the big companies, you could say. And that's what they want, and they were designing the market by means of being lobbyists. You have the black box at the bottom influencing the parliament, and then similar black arrows influencing the market conditions. And you will get, you could say, a black type of renewable energy policy. But then you can try to change the political process, so you get new lobbyists and give them influence, and that's this small green box coming, where we have the energy NGOs, a public debate, and other green lobbyists. And then you get the beginning of an innovative democracy, because then you start to be able to change the system, because there are new actors on the market. And then you can start getting some green policies also, 2 and 3 on the left. And then you will get another type of policy. You'll get more community ownership, for instance, and you'll get more democratic participation and so on. And this is very quickly, I have written about it, but I just very quickly has to say that we have to say that this is a change where you change to a sort of innovative democracy, because you need new political forces in order to get a new direction. I don't say that the old companies should not be there, but I say that there should be a competition from new political forces also. And this sometimes was the case in Denmark, that you had this kind of construction, but now the last 10 years we didn't have it. The last 10 years we had another type of, you could say, a black construction. And now we have got a new government which is close to this again. And in many years we had this balanced influence from the old lobby and the new lobby. And then a little bit, how is it? 5 minutes. A little bit on education activities. Clearly, these education activities are very closely linked to our understanding of how which technological problems we have, and which political problems and possibilities we have, and economic problems. So we have a study, for instance, called Master in Sustainable Energy Policy and Management. And the first thing is that the students should learn practical use of interdisciplinarity between social science and technical science. So they should both learn what is technically possible and they should also learn how can we implement what is technically possible, both, and they should combine it in all what they're writing. So no writing only on economy, no writing only on technology, always writing on both economy and technology. So it's very simple in a way. What is possible? How can we realize it? That's the two questions. So renewable energy systems, that's what is possible. And analyze the link between technological and the institution economic. That's how can we implement it. So we have a program. The first semester, we look at what is possible, and you have the company perspective. So it's seen from the point of view of the company that want to make a district heating system, or want to have some wind turbines, and or biomass or biogas plant. And the second semester is society perspective, where we analyze what should society change in its rules. Should you have another tax structure? Should you have other subsidies? Should you have other support organizations? And so on and so on. And the third semester, then that's a traineeship. That someone could come to York University, for instance, and stay here and have a project, and then have some guidance from York, people at York also. And, or they, as we have now, we have people have been in Thailand studying clean development mechanism. There's somebody in Azerbaijan just now, and South Africa. So when this is possible, then they can also go to Canada. Then you have the last semester. That's the thesis. And there it's very often written by one person. The study model, which is interesting also, I think, for you. When people study the first semester and the second semester, they are working in groups. It means 4 or 5 people in one group. That's, we think that it has some advantages, and 50% of the time goes writing projects, 50% lectures, and these things are combined, and they decide themselves what they write on. Often, individual third and fourth semester and fourth master. And the model is project organized, problem-based learning. It's always given problem that guides. So much of the time in the beginning of project, they find out what do we really want to analyze, what is the focus, what is the problem we want to solve, and the students decide this themselves. Group work means that they have a room where they are sitting, so they also feel at home in a small group, working family, you could say. This is one example. It's just a project from first semester company. They analyze, is it a good idea to have a GHP biomass plant in Worcester, a small city? And then they analyze what is technical, how should it look technically, and then they analyze also, is it economically viable for this company? And then I have a lot of second, third, and fourth semester projects, and most of them are just from the last year. There was one woman from Lithuania. She wrote a big and good report on policies for house insulation in a city in Kaunas, and she found out what is consumption, how does houses look like, and how can you, which type of rules should you implement in order to make this happen. This is the last PowerPoint, but it's a little bit long one, so I can make it short. So in fact, she was from Poland, and is from Poland. She wrote a big report on policies for better use of biomass in Poland. Instead of just burning it in a big power plant, how can you make it more advanced technologically? And then just now, Maria from Greece is staying on a small Greek island and writing on 100% renewable energy on a Greek island I forgot the name of the island, but she's inspired by Samsø and Søren Hermansen's Samsø 100% renewable energy island. She submits her report in a month or so. And policies for renewable energy in South Africa. I need an H in Africa, South Africa. This was on feed-in tariffs in South Africa. Policies for a sustainable energy plan for Latvia. 4 women made this report, a fantastic report. In fact, they went to Latvia and interviewed a lot of people in Latvia and saw saw how a group of men in an electricity company did not sufficiently respect it when 4 women were posing questions. So they learned more than the people in Latvia thought they learned. And then one American student made, in fact, a fantastic report on, it's some years ago, renewable energy in the US. And another group made district heating in New York. I thought it was a little bit ambitious, but they wanted to make it. And then CDM projects in Thailand. And all these projects have technical scenarios plus institutional analysis and policy formulations. Thanks.
That was an excellent presentation. Now you can begin to envision how we're putting together our efforts in this part of the world in collaboration with leading institutions in other parts of the world. On the second half of this panel, you will hear how St. Lawrence College, which is a few 100 kilometers from here, it's also doing some cutting-edge training and collaborating with, for example, leading institutions in Husum, Germany, to be able to train Ontarians and people from other parts of the world in how to become wind trainer, not wind trainers, but wind power experts. And you will also hear from another colleague that it's doing some work with Red Screen to create opportunities for training in Africa. That'll be after the break. We will have a coffee break very soon. And before the coffee break, we wanted to give a few minutes of your time to provide some questions to the panelists. There are, again, people in the ground taking written questions in case you don't have time to have your question posed. We will take up your questions, or maybe you're more comfortable not speaking but providing your comments. All comments are valuable and questions are important. I think what I want to emphasize from what we heard was that the political commitment that has been provided in Denmark has made it possible for people in the ground to make the transition to renewable energy. The important context that we have here in Ontario is that we have that political support as well. Last evening, the Minister of Energy was in an event here in the Steam Whistle Brewery. Don't tell that to the Premier. But he spoke about how he is personally providing support for the type of things that you're interested on and that we're discussing in this panel. So we need to help our political representatives to direct their attention to what I call the Achilles heel of the equation, what David was talking so clearly about how people can actually learn by doing, and also people that are working on the knowledge separated from experience can come together to some common understandings on how to do these transitions. These transitions are not technical, they're not policy, they're not marketing, they're all of the above and then some. And the challenge for us is that in this province there is a backlash against renewable energy, that it's being orchestrated by people for different reasons, and we have the responsibility to provide some specific answers to people that are bringing misinformation in the one hand, or in the other have serious concerns about renewable energy. And also we need to provide the training so people are capable of actually doing the technical aspects that are essential to make the transition possible. So within that context, I wanted to give the floor to you now to pose some questions to our panelists, and we will be here after the break as well with 2 more presentations. So the floor is open. That microphone, I think, can work, and that one as well.
My name's Keith Brooks, and this was a question about the Denmark case. You talked about how you deal with excess power. One of the criticisms of renewables here in Ontario is that it's intermittent, and we need gas plants to deal with peak load when we can't quite get what we need from our renewables. How do you manage that? Like, not just dealing with the excess, but perhaps when there's a shortage. How do you ensure you have sufficient energy that you don't need to have peaker plants or whatever it would be?
in a way, I'm the wrong way exactly to answer it. But I know what our system people say, and you can see it if you ask me to send this report I talked about. But it's easy the first years, because also easy to 2020 and 2000 because we're still not having 100% renewable energy. We still have gas, and we have some gas power plants. And we also have 1 or 2 coal power plants left. So they are just working when there is no wind. Then later on, it becomes more difficult in 2030, 40, and 50. I don't know where it becomes more difficult, but you need new solutions. And we use some biomass, but we have rather much restriction. We are not as lucky as Canada to have such a lot of biomass. And we had a lot of discussion, what can we do and how much biomass. And some would say we have a lot, but because then they will change having maize and this. But we didn't like this having just monoculture everywhere, so we could not just use biomass. So we also made, and that's where I am not good enough in the technical thing, we also made syngas, wind together with biomass, and that way got much more biomass, could store it also, what's coming from the wind. And so in 2050, it's a system of wind and some biomass and some syngas from wind and biomass. And then the storage is not that problem is much less, because we can always store heat, so that wind is not that intermittent in our system as it is if it's just an electricity system. So it's because the heat is taking all the peaks away, and the bottom, as we have a big wind capacity, the number of days where we don't have enough from a wind turbine for electricity are also fewer than today with a small wind capacity. So I don't know whether my technician or the technicians in our group could answer it with a single technology answer, but they could answer it by saying with this bouquet or this set of technical equipment, so much, a little bit hydrogen also, and some biomass, and then combine heat with electricity with electric cars, and then all these things together makes it possible and to do it. And anybody can go and see this energy plan model where they are simulating the system and describing all the techniques and technologies and see how it is solved. And anybody here can also mail me, and I can mail the report back where you can see how it is done in detail. So it is simulated hour for hour how it works, and you can see which technology is used in this period of time. So, and our 100% renewable energy scenario for 2050 also includes transportation and also includes a certain amount of air transportation. So it's, yes.
Add something?
Yep.
Okay. Is this one? Okay. Where we're at now, or in Ontario, of course, is single digits of percentages, right? 1 and 2, so all others are below 1, and wind is coming up to 2, and so on. And I think at this point, the question is more rate of change than the aggregate. And so you need some technologies in there that, of course, the fear is that, the clouds go in front of a large, commercial scale PV array, and suddenly there's no output. And your conventional sources can't spool up that fast to make up that shortfall. But I think that's where your, kind of smart grid initiatives, where you're going to control your load. So not that you have to turn those loads off for long periods of time, but you just have to buffer that transition and give the conventional sources time to come up and meet the load. And of course, with the gas peaker plants in, they're quicker, and then, you know, the hydro is behind that. You have to control the loads, you know, do demand response in a real-time basis. And I think that's where I think people will start to see the advantage of truly distributed energy, where I'm talking about 5K on houses rather than the multi-megawatt plants, you know, in southwestern Ontario when the load is downtown Toronto. It becomes easier to manage some of those loads when the transmission, you know, is basically on the same building, right? You've got supply and load, and so if that building's array is going down in power, you can make that building's air conditioning system lighten up its load immediately and then come back, so that the actual temperature in the building isn't going to oscillate wildly, but it gives the conventional sources a chance to come back. But it's a big communications, and we have to work across you know, LDCs, and that's where I see, you know, all of this is, you know, amongst educational organizations, and that's, you know, what Jose's trying to do is so important, is get everybody who's in education working together so some of these complex issues can be worked out.
Yeah, if you give us 2 seconds, I notice there's a lineup and we only have time for one more oral question, so I would encourage the people that are, I will take your question, sir, but the 2 other folks, please write down your question, Dorothy, if you can give it to Sarah, and we'll start the next session. We want to end on time and start on time to be respectful of your time. To answer quickly what this gentleman asked, the Electricity Distributors Association in 2009, I believe, asked us to help them with a tour to go to Denmark. And the purpose of that was to answer the question that this gentleman was posing. So if you go to the website of either the Markham District Energy website or the Electricity Distributors Association, you will see a movie where we explain how you can do these things. It's not an Oscar-winning production, but it actually does it, in my opinion, in a very clear manner. And why am I making this point is because at the moment, the Electricity Distributors Association has a discussion paper out where they're making the case for new investment on the system. So the question is, are we going to invest on the old technology for the system, or are we going to invest for the 21st century and get a 21st century smart grid? That's what I wanted to say. It's called the Danish Experience, and it's on the websites of the Electricity Distributors Association and also Markham District Energy, which is a combined heat and power facility in Markham, right here. Much better than peaker plants, actually. You get 2 for 1 there.
I just wanted to just add to what has been said, that grid scale storage system would be a good way of dealing with intermittency and reliability issue, and would allow high penetration of renewable into the grid system. So there are lots of grid scale storage system that are gaining attention in the market right now. And the lithium-ion flywheel, supercapacitor, pump hydro, those are technology innovation that is coming to address renewable integration into the grid system.
Okay, so our last question for this session, please. If you can start with your name and the question, please.
Can you hear me? Flip the
this
switch.
one works. You want to walk to the podium?
Sure.
Easier.
Hi, I'm David Smith. I was actually going to also add to the answer to the last question. So this isn't a new question. Is that okay? Is that allowed?
If you can do it in 30 seconds.
I can do it in 30 seconds. It's just something that comes up a lot with the having to meet the demands with renewables, which are intermittent. And I think it's important to point out when people ask those questions is that it's not completely a new problem. That we have demand that changes to some extent all the time with when people turning on and off their lights. With the way people use energy, it's inherently intermittent. And that a lot of the generation sources don't match use, like nuclear, which people don't often criticize for not matching the loads. It's a base load, and so you always need something that's going to help match your demand at your production side. So having to meet those peaks isn't a new problem. Ramping up and down quickly is the new problem. But you can't, when people are criticizing renewable energy, because so many people do, we all have our crazy uncle that we have to justify why we work in wind. It's important to point out that that's not a new problem, and that the grid does have means of dealing with that, and they just need to somewhat be improved to deal with quick ramp ups and ramp downs. That's all.
So the first questions that we have for you, they're all now in the from you, is what concrete steps need to be made to better organize the renewable energy sector to promote public support and public action? What can we do to overcome the widespread disinformation campaign waged by renewable energy opponents? These are two questions, actually, they're not one. And I will tackle the first half myself to give my colleagues the opportunity to read all the bullets. So what can we do to overcome the widespread disinformation campaign waged by renewable energy opponents? We at the Sustainable Energy Initiative have a group of researchers that are right now going through the peer-reviewed literature to actually provide some specific answers to some concerns that people bring forward. So do, for example, wind turbines cause your family to be ill? Will the sound cause you to have problems? Et cetera, et cetera, et cetera. We are at the moment developing those answers to such type of questions in a rigorous scientific peer review manner. We want to be able to provide the people of Ontario in our website answers that are scientific in nature, peer reviewed, because in the peer reviewed literature, people that publish there have to have their ideas, their data, double check, triple check by people that are experts on the topic. It's not okay to make a statement that it's based on conjectures or invention or self-published research. Those are not proper scientific sources. So we will be addressing this. This should be released soon, hopefully within a couple of weeks in our upcoming website. Now, what can you do about that? It's very simple. You need to listen about the concerns of local people, particularly if you're in the development end of the spectrum, and make sure that you address some of those concerns, because concerns are valid. Whether that they're properly justified or not by science, that's a different story. But concerns are concerns, and people deserve to have their concerns addressed. And it is incumbent amongst renewable energy people to do better than the rest. So let's make sure we do renewable energy projects that are not only safe, but also very, very good for the local community. So the local people will actually feel that the transition is better than the status quo. In terms of what concrete steps need to be made to better organize the renewable energy sector to promote public support and public action, I think it's important to support. How many of you are here from Ontario? If you could please lift up your arms. There's a lot of you that are in Ontario. I think it's important to send the current government, the new government of Ontario, a clear signal that there is support for these things within your own efforts and communities. So they feel actually empowered to do the right thing. There was a clear definition prior to the election between the different political parties of how they stand in regards to renewable energy. And I think it's important now to give the government a clear signal that we're here to stay and that we're serious about the business that we're building and the activities that we're conducting. They need to hear that from you because this is a democracy, ladies and gentlemen. And Frede spoke about energy democracy. We owe it to everybody in this province to do good projects and also to ensure that there are local benefits. The next question was directed particularly for David. What standards and certification exist and how can they be improved? And the second question was, should Ontario move forward with a NABCEP-like certification process based on the Canadian Electrical Code? Would you mind, David
Sure.
and Babs, to answer this, please?
Okay, the NABCEP, for people who don't know, is a system out of the U.S. about qualifying people who already know what they're doing in PV installations. Mostly they have solar hot water as well. So it isn't so much an educational program as a certification. You already have to have installed a certain number of systems and showed competency. And that could work here. The difference that we have, it tends to come out of, in the U.S., believe it or not, in many states, they don't actually have a restricted trade as electricians. So anybody can do electrical work, and that made it a little bit more of a Wild West. So that's where NABCEP kind of came out of. I think something like that needs to be here. Several attempts have been made to bring NABCEP here. Certainly Ontario practitioners have gone and become NABCEP qualified. The piece of paper is only a marketing tool. At this point, it holds no weight. And I think that's something that the colleges could do with getting together, because we, as that slide I showed indicates, the ESA recognize something other than an electrician for doing this work. And so there is no, right now, certification for that. And I think if colleges were to get together, if the industry were to get together and say, we now have a trade certification other than an electrician who should be doing the DC array installing, that would happen. And I think probably the Ministry of Education kind of expects that to happen. The sooner the better, I think, that we push that forward. But it's an industry and college initiative needs to drive that ahead. And the one thing I did miss out on my presentation, where I noted that you do have this separate designation of someone other than an electrician doing the DC wiring. The other part of that you should know is ESA inspectors don't go on the roof. That has been designated as an unsafe work area for them. So we have an unregulated trade installing electrical equipment on roofs, and it's not being inspected because, close-up inspection, because the inspectors can't go on the roof. And the equipment is inherently different in that the fuses and equipment that you normally think of clear faults, the whoops, don't work. The only thing that keeps a PV array, the DC wiring, safe and working right is a good, solid installation, quality of workmanship. And so the question, how quickly can we really get an organization, a certification in place to take place of, an Ontario NABCEP certification?
Perhaps you want to try that one as well?
I totally agree with David, and I think standards and certification, is usually a challenge to emerging new industry, and until the industry gets to a point where they see safety concerns, and then the industry will mobilize itself. But I totally agree that it's time that the industry and the colleges and institutions come together to start looking at standard, whether we would import one from established market or define new ones. But I think we are getting to that point where we need standards.
I actually want to say that this is a very important point that actually merits some further elaboration. I see that Corinne is on the audience, and what we could do is, since we have two colleges, a university and a training center on the table, we will take this important item up. We have a conference coming in April of 2012, which we will bring you a more specific answer to this question. This is actually something that needs to be actually thought out in a very organized manner to provide a proper answer. I want to assure you that we will put it on the agenda for that. And also, Professor Frede Hvelplund wants to provide a question coming back to our first set of questions, please.
Yes. Is this working?
Yep.
Okay. We in Denmark, we at present have a law saying that anyone making a wind turbine project should offer at least 20% to the local residents. So this is a must. They have to do this. But I think this and in our last proposals, we propose that this should be changed to at least 60%. My personal opinion is at least 100%. But in the group where I worked, we could agree on at least 60%. And so I think that it is a must that local and regional organizations and people have the first right to the resources. That's if not, you will get a lot of opposition. That's the first answer. And then the answer to the next thing is, what can we do to overcome the widespread disinformation? Then I think we always, and I know you always have done, also has done it, but we make alternative plans showing that what is possible and documenting it. And then I have a proposal for our collaboration also, that we have an energy plan model where you can see what is which type of technologies you need to cope with intermittent energy. But this is rather complicated to use it. So it would be good to have a school child version of it, so that you can play and say, okay, now we put one more wind turbine. And what happens to intermittent? Okay, we need to have a district heating. You need a certain number of electric cars. So we need to have a school child and politicians and all common people who don't work with it version. So that you can just play it like any other game almost. So you can see and learn from it. But I never succeeded to get anyone to want this. So I hope that we can collaborate on this.
I actually think we can persuade one of the bright master students that has expertise on software development to take this challenge. This is a very, very good proposal. I very much like it. And I think we have one outstanding question before we can start the panel, which is, how do you integrate land use planning with energy system planning? And what are some examples of international and local best practices? One of the best examples is Denmark, in my opinion. I think it was very important. Most people know that in Denmark, 22% of the electricity use comes from wind power, but less people know that district energy and combined heat and power are very important contributors. So perhaps you can tell us the genesis of how the communities of Denmark were encouraged to do energy planning, to come up with good planning strategies for energy.
I think that's a big question. Yes, because there are many things, really many things. First, you have to get this district heating, and they are all, at least in Jutland, where I come from, they are all owned by the consumers, or the municipalities, mostly consumers. And I think there are 600 of them, something like this, and they can react very quickly on wind power. And then the land use, I must say, I'm not a specialist in it, but I think a main idea which I've heard, because I don't look so much at what we have done, I think I look at what we should do, because there are some problems with acceptance now. And I think that I heard one mayor in one region in Denmark, he made a really good proposal. He said that we need this capacity in our region. Now we want to, and this is good for our region. We'll get money from it. We'll earn from it. Which idea do you have where to place them? So he posed the question to people, where do you think they should place them? And this is not a number, but he was successful. They got a lot of suggestions and really a high capacity, which they didn't get anywhere else. So the Danish people are like, if you ask them what, and I think that's common for many people in the world, if you ask them what is a good idea, then they will follow. But if you say, here you have a wind turbine in front of yourself, then they will resist even if it's a good location.
here in Ontario, one of the biggest problems that we have at the moment is that the different planning departments are not talking to each other about what the potential for energy is and energy planning requirements would be. So we have a situation where one part of the planning infrastructure of this country and this province, it's not talking to other branches of the government to do coordinated, integrated planning. And that is a very big problem. However, it's always good to emphasize solutions. In Guelph, there is a very interesting process coming up to do proper energy planning. And I think it's important to highlight that in Ontario we have some also practical examples. And fortunately, the mayor of the city of Guelph got re-elected, and she's a very, very avant-garde thinker on how to do these things. She has created an opportunity for the local distribution companies, the universities, etc., to work together in a strategy to ensure that that part of Ontario succeeds in energy planning. The last thing I want to say about this is we're talking about new ideas about how to move forward in this province. Well, we used to have in this country until recently, very good programs that would allow people to come into your house or into your business to do an assessment of what you could do with energy efficiency. These programs have been diminishing in support from both the federal governments and the provincial governments. I think it's time to restart a new initiative where people can come to your homes and small businesses and not just do an assessment of what you can do with energy efficiency, but also what you can do with renewable energy in your home or in your businesses or places of work. And then link that assessment to some opportunities to do strategies of energy efficiency and renewable energy at the residential and small scale. I think this is a very timely idea that should be implemented as soon as possible. And I'm putting it on the table because the context of this conference is to come up with additional strategies. And right now we have a situation where the people that were doing energy audits are left in limbo. And we have the people that are doing feed-in tariff installations are being left in the limbo. And I think it's putting them together in a way that we can know what is possible. Because if we quantify and measure what can be done, then we have a clear idea of how much it's going to cost, what is possible, where is the low-hanging fruit, where are the best opportunities, and most important, then we can develop the financial instruments and also the research capacity development, local capacity training strategies, etc. But we need to start somewhere, walking before we can run.
Just a short addition to what I said before. The way the present way of planning is that the government says how much they think each municipality area should have, and our municipalities are rather big, and then the municipality decides where to put specific places where you can have wind turbines, and then in accordance with nature requirement, for instance, and other requirements. So there will be specific spots where it's allowed to put wind turbines. And this has been working, but it has some problems now because people don't get sufficient ownership, and then people will resist a big wind turbine put at a specific place from a municipality, and we are all the time trying to change this. And for instance, we in our energy group will change this because there are problems in placing because of this top-down model. I agree that we have to be cautious with nature problems and environmental problems and also neighbor problems. But they can be solved if people own a big share and if they participate in placing the wind turbines in this process.
As you can see, we need to move on to the next panelist. Unless the current panel has some additions to make. Do you want to make one addition more, or shall we wait until?
Do you want to do it at the end?
I would prefer,
yes,
just
good.
because we have
Let's
two
do it.
speakers. I think it's important that we add up the two speakers that are about to present. I would encourage, if you have a question, to please write it down and to give it to some of the people that are taking. If you could please lift up your arm. Sir, we cannot hear you because you don't have a mic, but may I ask you to please write your question down, because we need to open the panel for the next two panelists.
Sorry, I'm not asking a question. I'm just talking about the third question. The local example that somebody has asked for is the waterfront Toronto. That's at international level, and they are integrating land use planning and energy systems.
Thank you, sir. The next strategy that I propose to you is to hear the next two speakers, because then you will have some other pieces of the puzzle of the panel that we were trying to put together. So our next speaker is Mr. Adegboyega Babasola from St. Lawrence College. St. Lawrence College has one of the best programs in the planet on renewable energy training. And they say that the proof is on the pudding. The graduates of these programs have a very, very high employment rate. Would it be 100%, Babs? 95% employment opportunities. So he prefers to be called Babs. So with all due respect, if I can introduce you as Babs. So if you could please give him a round of applause so he feels comfortable.
Thank you. Okay, so St. Lawrence College is based in Kingston. The main campus is in Kingston, and is a tri-campus college. We have campus in Kingston, in Brockville, and in Cornwall. And it's a small to medium-sized institution. About 6,500 students, full-time student, 20,000 part-time and online and students. Some of the statistics that we've got that got us really excited with our program is we're number one in the province for graduate employment and employer satisfaction. But 90% of our graduates find job after graduating from the program. 95% of our employers, of the college and student employers, are satisfied with the education preparation that St. Lawrence College offers the students. And about 84% of our graduates were satisfied with the quality of programming that they go through at the college. We also are leading and taking steps in green initiative, and just a very few of them I've noted here. And the very recent one that we're doing is we're installing solar PV panels module on our roof in Kingston and in Brockville. 250 kilowatts system is going on the roof in Kingston, about 100 kilowatts system on the roof of our Brockville building. That makes us to be, that's by far the largest installation of PV that any post-secondary institution would embark on in North America. We're taking advantage of the feed-in tariff program. We're also taking a green initiative. We did energy audits of our facility, and also upgraded some of our facility. That resulted into reducing our carbon footprint by 1,400 tons per year, reducing our energy bill by about 600,000 per annum. Some of the programs that we offer, to support the green industry is our energy system engineering, technology and technician program, The Energy System Technician program is a 2-year program. The Technology program, a 3-year program. This program started in 2005, long before the introduction of the New Energy and New Economic Act that was enacted in 2009, and producing students, to support, sustain, and advance the renewable energy industry. And some of in the program, we also offer some entrepreneurship, training, because at that time there wasn't like job really available for the students. So we developed students that would go out and they were world changers. Start up their own business. They learn skills, so risk-taking skills, project management skills, report writing skills, just to prepare them for the new industry. And some of the facility that they have for training is the Energy House, an off-grid system, that provides students with hands-on experience on, designing solar PV system, micro wind system, and installing, implementing, integrating the system to building. So they had this. The student actually built this facility themselves. So they really got a hands-on experience on how to do installation. We also have a wind turbine program in partnership with BZEE from Germany, and with the resources we have, at the Wolf Island, a 200 megawatt wind farm. We develop a wind turbine program. So students have real hands-on experience, real-world experience on how to maintain, how to operate the wind turbine. Knowledge or an experience in electrical and mechanical components was also part of this program. At the very left side, the picture is the former Energy Minister of Ontario making a presentation of the long-term long-term energy policy, energy plan of Ontario, and he came to our wind turbine facility to make that announcement. Next year, we are introducing the geothermal technician program. This program, we already have the approval, and we're launching it next year. This program we train, we produce, geothermal technicians, to support the geothermal industry, and they will learn how to install and design a system. The program is in collaboration with the Canadian Geo Exchange Coalition. Now, very recently, the Ontario and federal government of Canada, saw the relationship between colleges and the community, and how the colleges are able to support the local economy to innovate and develop new products, improve existing products, and help them to be very competitive in a very tough market. And so a pot of funding came to the colleges, and St. Lawrence College, took advantage of this opportunity and got $90,000 per year, to do 12 projects, gotten from the College Ontario Network for Industry Innovation. And we also got $155,000 to do, fairly large project, industry-focused project, and we got it from the Federal Economic Development, Council, looking at Southern Eastern Ontario region, and supporting the industry within the Southeastern Ontario region. And very recently, in 2010, we also got a $2.3 million support from the Natural Science Engineering Research Council of Canada to really develop an applied research capacity and capability, to support the emerging renewable energy industry. So the NSAC grant was really focused on energy system integration of renewable energy technologies. And that was actually what got me into the college anyways. So our focus mainly at the Sustainable Energy Applied Research Center is system design, new technology development, product testing and validation, proof of concept, system optimization, problem solving, prototyping, commercialization, and we leverage St. Lawrence College resources, faculty, our students, and researchers such as myself, and our equipment and our infrastructure to support local and regional small and medium-sized enterprises, to support them, assist them in innovating. The industry is still very fragile. A lot of the industry don't have that capacity, to improve their product. So that grant helped us to support those industry. And one of the things our collaboration model is we get in-kind contribution from the industry in terms of their hours that they get involved in this project, and some of them also provide cash contributions, and we match that with our grant and our NSEC grant, and we help them to develop a new improved technology, and we don't lay claim for any of the IP. We have IP handed over to the companies. And some of the projects that we've embarked on is in collaboration with Queen's University and about 16 companies, we developed a state-of-the-art solar PV real-world test facility that provides performance, data, for solar panels. And we have weather station, state-of-the-art weather stations, and instrumentations that provide the data. And so the first project that we embarked on is to study the effect of snowfalls on PV performance, because right now some of the modeling and simulation software in the market do not put into consideration snow losses. And so, payback period not, sometimes a predicted payback period are not the same as actual. And so we're providing that data, that information to our industry partners. As I said, we have about 16 industry partners involved in this project. And some of the other projects that we've also done that are not PV related, energy efficiency. We did an energy audit for a cold storage facility in Trenton, and looked at opportunity for energy reduction and conservation that would have a great impact on their electricity bill. And we provided them with that information, for implementations. And so our students really get involved in real world, challenges, and get them really prepared as highly qualified personnel, ready to face real-world challenges once they finish their program. So another project that we also are working on right now with a local industry partner is the development and prototyping of an hydrogen delivery system, for fuel cell application. So we're sizing the component, putting all the components together. This we believe will be a game changer in hydrogen delivery, because we're using a solid salt to produce hydrogen. Very recently, about 5-6 months ago, we started having concern about the penetration limit of renewable, that could cap the sustainable energy industry. And based on that, we took leadership to forming the Kingston Smart Grid Research Consortium. This research consortium include the college, St. Lawrence College researchers, Queen's University, the Royal Military College, Kingston Utility, and several private companies. And we came together looking at demonstration project on electric vehicle and charging station, how the introduction of this new innovation will impact the local grid system. And we're also interested in utility scale storage technology, and how that could be integrated into solar PV, wind turbine, to resolve intermittency and answer any reliability issues. And we're also concerned about energy management, energy response management, communication information, and also policy. And these are some of our industry partners that we've been working with, and the list is growing. Thank you.
That's an excellent presentation, Babs. And now we encourage you to please write down your questions, give it to the representatives that are going to be on the floor taking them. And the next piece of the puzzle, you have heard now of here in Ontario, we have the opportunity to receive and acquire knowledge in a variety of settings. It doesn't matter if you are in the do-it-yourself end of the spectrum, or you're an entrepreneur, or you are a student. There's now in Ontario some significant opportunities for you to get knowledge and to be able to do a difference in these new emerging opportunities. Now we're going to speak about something that is an equation with e-learning. The 21st century permits some very interesting things that the 20th century did not permit. And one of them is to be able to be with different cultures on a regular basis through the new tools that we've developed in this planet. And this next story that will be told by Charles Diarra has to do with a software that was invented here in Canada by personnel of Natural Resources Canada, that in the early 1990s developed with pragmatism and altruism the new program called Red Screen. And the idea was to use this renewable energy technology screening tool to be able to enable people that are doers to have a very clear idea of what you can and cannot do with different energy systems. And this tool has evolved over the years, and Charles Diarra will be telling you how he's working with people in Africa and other continents to use Red Screen to be able to access e-learning opportunities, and how he's conducting these efforts on behalf of the United Nations agency, UNIDO, in collaboration with Red Screen. So round of applause, please, for Charles Diarra. Thank you.
So my presentation is on the Advanced Rescue Training Workshop for Sustainable Energy Education and Implementation in developing countries. The program is being initiated with UNESCO. UNESCO, I think most of us know what is UNESCO, the United Nations Program for Education and for Education, Science and Education Organization. And then you have UNIDO. UNIDO is the United Nations Industrial Development Organization program. And together with the Red Screen International, they have been promoting Red Screen as a tool for education, training, and development in developing countries. And this is because they found that for us really to go for a sustainable development in terms of energy need, we need the training and we need the education of people. So this program is being sponsored by both organizations of the United Nations, UNIDO and UNESCO. As an introduction, UNESCO has recognized that the supply of skilled workforce is a critical element in the transfer of technology, and due to the enormous need for institutional and human resources development. So we need the education, we need training, and also we need the human resources to be involved in that process. UNESCO has launched a renewable energy education and training program as an instrument to help the international community to address the energy issue. And this also to help the rural community, those who are located in remote area, to remove the barrier to the diffusion, the distribution, and the diffusion and development of renewable energy technology through demonstration project, through implementation of solar renewable energy technology program. And also to promote capacity building, training and education, because without training and without education people, we cannot remove those barriers. Most of the people who are really against renewable energy technology, in most cases, it's because maybe they don't really understand the technology, they don't know the limit of the technology. So UNESCO has launched this initiative that while we are implementing renewable energy technology, we should let the people know the barrier and the constraint linked to both technology. And then enhance the energy efficiency program in developing countries. We are saying it's not a matter only to produce or generate new technology. We can continue just to produce a new generation, but also have to to take use of what we are using and make use of what we are using and use it efficiently so that we can save. And that energy we are also going to save is also greater source of energy. So the program also include energy efficiency measure program. The context of that one is most of us know that we have almost more than 1.4 billion people who do not have access to grid-connected electricity. And the potential of renewable energy is generally greater than the demand in most countries around the world, and particularly in developing countries, where in most countries sometimes you have almost 12 hours of sunshine during the day. There's no winter in many countries, in most developing countries, so the potential of renewable energy is huge, and yet they do not have access to electricity. So renewable energy is a great potential for them. Based on the Intergovernmental Panel of Experts that was organized by the United Nations in 2011, so it's really recent, it indicated that less than 2.5% of the available renewable energy technology are exploited in the world. So we are only exploiting only 2.5% of renewable energy available in the world. So there's great potential which can still exploit. The objective of the program is to promote institutional and human capacity building to reflect the need for education for professionals at different levels of responsibility. That is, in that program, developed by UNESCO and UNIDO, we are involving professional education, universities and colleges into the program in the different countries to be part of the program, and also to involve the human being of the program, because they are integral part of the program. It's also aimed to strengthen the competency for favoring exchange of knowledge and the best practices, and also to enhance the use of application of renewable energy sources, develop a network of train-the-trainer. So what we are doing is to train people who will be able to train other people in order to promote the use of renewable energy technology. Here you have, you have here a picture of a workshop which is being organized. It was organized by the UNESCO under the Solar School program, where people are learning software on how to implement renewable energy technology. The main activities of the programs is organization of training program at different levels, including continuing training for professional, decision and policy maker, researchers, engineers at the universities, technicians also. For example, the last rescue training program I had involved university professors who are really trying to put to set up the program and make it part of a university program at the university level. So the training program I had was to train more university trainer to be trainer of students in the university, and also to be part also people from different ministries, because we need it to be implemented. So UNESCO and UNIDO also make sure that people from different ministries of energy, ministries of environment, attended that workshop. So we was high-profile people who are head of a department, director of program. They were also part of this training program, for example. It also aims to design and field implementation of training tools and learning teaching, promotion of national and regional training center of excellence at the regional level, and setting standard and definition of energy training curricula. So this comes back to what we were saying, which kind of standard are we going to set up for the training. This is just a figures for other people participating at the wrestling training program. As wrestling training program software, I'm definitely sure many of people who are attending here already know what is the wrestling program. So it has been developed. Professor Jose just mentioned it. It was developed in Canada here, and has been an international program used all over the world. More than 200 countries are using this program, with almost 2/3 of the population, because the program is translated in different programs. And the beauty of wrestling is you can work in English or you can work in English, and if your customer is in German, then you just do everything in English, and then you just translate it to German and give your report to him in German. So you don't need to worry about it. If it's in French, don't worry. You don't speak English, do your work in French, and then the translation is there. You change it, and everything is changed into French, into English for you. So that's one of the beauty of a wrestling training program. And very few software really have that type of possibility for you to work in different languages. So the software is available in different languages, and you have a detailed user manual and a case study based on college, university level training courses. So if you go to the program, most of us are already using wrestling program, so you know it has a manual for training, and you can even learn it on your own once you have the basic for a program. The objective of training, which has been doing, is the overall objective of the wrestling workshop is to build up a regional training trainers, as I mentioned, also network, and to build a wrestling training network on renewable energy and energy efficiency program. And the beauty for wrestling program is we just have the new version, which we call wrestling version plus, which include energy management. Some of us maybe, and some of you may have already visited the new program, wrestling version plus, and it's really focused on energy efficiency program. The wrestling also does evaluation tool. It's an evaluation tool which will be done as part of being applied by the network. It means in the training program, for example, by UNESCO and everything, we also want to include other programs, for example, like HOMET, which we also want to include into that process and learn and teach people how to use it so that we have a very full package of energy program. The specific objective of the workshop is to provide training on financial, renewable energy and energy efficiency project analysis by applying the wrestling software tool. This is to ensure a high-quality training and follow-up support for the participant. In the program we are doing with UNESCO and wrestling, you don't just go for a 1-2 days training program and say, okay, guy, bye, we finished the workshop today, it's okay. So any training we are having with UNESCO and UNESCO, we have at least 10-day or 5-day follow-up program. It means after the training program, you will have to come back to the participant. You have 10 days for the follow-up, contact them on what we are doing, or if they are having some case study, for example, and you will help them to finish or build their case study on the energy efficiency or energy technology program. So it's compulsory for you for the training. After the training, you don't just limit to a couple of days of training. You will have to set up at least 5 or 10 days, depending on how many participants are there, for training follow-up program, to make sure that everybody will be able to use the program. The beneficiary of that program are the direct beneficiaries and participants of the workshop, are Renewable Energy and Energy Efficiency Training Institute. For the last seminar I had was from the ECOWAS, this is the ECOWAS member states countries. This is a sub-regional country, a sub-regional organization with 16 member state countries. So during the training program, you have professors from a university coming and head of department of energy from different ministry or energy coming to attend the program, and also people also in the finance, Ministry of Finance, we were also coming to attend the program. And we want to make sure these are people who can take decision on both political and social level to be able to implement the program. So the training also, at times the training includes what we call a certification program, but it's not a compulsory aspect. That is to certify people who, during the training program, will be identified as being able to do rescue training program, for example, at national level. That's another problem, but it's not compulsory. If you want, then you can pass the certification program. Renewable energy, clean energy here means energy efficiency, of course, and also renewable energy technology implementation. And rescreen does give the opportunity for you to use all of those facilities in terms of how to implement renewable energy technology and also the energy efficiency measure, especially with the rescreen version plus. It's a very good, excellent tool for that. How much energy do these studies typically cost? Rescreen program is able to give you that opportunity to know how much I'm going to spend and how much I'm going to recover my money, because you have the financial analysis of it, you have the energy model of the program, you have the environmental energy, analysis of a program, and also economic analysis of a program. So it's really a very good tool in terms of renewable energy technology system implementation. So the rescreen program is a platform. Amethyst is a platform which can help you, for example, to link different people who are really in the energy sector, be the people who are tender, be people who are developing, be people who are owner of a program, people who are supplier of a product. During the rescreen program, you have the opportunity to interact with all those different programs, with all those different people who are active in the energy sector. I think that's all. Yeah, I think that's all for my presentation. Thank you very much.
Merci beaucoup, Charles. Ça, c'est magnifique. Alors, nous parlons avec l'audience. It's now time to open the mics on the floor. We will take questions in both mics and also written questions to honor those of you that wrote questions for us. You want to be first, Stefan? Just to provide a little bit more context about the Red Screen Train the Trainers initiative that Charles was talking about, there was a big conference of Red Screen International in June on Niagara Falls, where we created a network of train the trainers that Charles is one of the professors that represents one specific region. And there is a professor from India called Professor Kishore. There's a professor from Thailand, a number of professors from Europe, which represent different parts of the world. And we created this network to create some of the solutions that Charles was talking about, certification issues, etc. For us, this is very interesting because we are learning with one of the best tools to do e-learning, because we need to develop a lot of curriculum that is available on e-learning format to be able to actually tap into the 7 billion planet audience that has an interest on energy. So thank you very much, and we'll start with Stefan Sanger from the World Wind Energy Association.
Yes, thanks a lot, Jose, and also thank you to the panelists for very interesting presentations. I think it's indeed a very important topic, and I would just like to add to that what you've mentioned here, that we published, or this week, can you hear me well?
Yeah.
Okay. This week, an important study was published officially that I think should be relevant for this. We did, as International Renewable Energy Alliance, together with our partners and together with the International Labour Organization, a global study, I think that's the first study of that kind, of the job requirements of the global renewable energy industries done by each technology. So we did the wind part. So that study was published now earlier this week. I just got that they finally published it on the website of the International Labour Organization. The website is www.ilo.org. So those who are interested in this and the global status of which skills are required, what's the current status. There's a quite good global study. Of course, that's not going too much into depth, but it gives a very good global overview of what the job and the skill requirements in the renewable energy sector worldwide are. Thank you.
Thank you. And because Stefan doesn't like self-promotion, we can say that in the World Wind Energy Association conference in Egypt, there was a PowerPoint presentation done about this research. So I think it will be posted on the World Wind Energy Association website in the near future.
Well, the presentation in Cairo was done, of course, new jobs that played a major role in Egypt at this point of time especially. The first results were presented there, but not the final study. And we hoped that we could present the study in Cairo already a bit more than a week ago, but now finally, because ILO took a while to get everything approved, now the full study is available, so you can download that. It's more than 100 pages. So that's available on the website of the ILO at the moment, and we're just also trying to do some joint press release on that. That's not out yet, but I thought I would like to share this information with the audience here.
Yeah, and I thank you, Stefan. And the last thing is also the World Wind Energy Association published an e-learning wind manual. I think it was in 2010 or 2009. And I think I have one of your DVDs. Perhaps if people are interested, they can talk to you on the break about this as well.
Well, we have basic information about how wind farm planning is done and how wind turbine works. So that's where I think we get, especially from many students, they visit the website and they get information there. So it's basic technology information.
Thank you. Thank you very much,
Thank
Stefan. So we'll take your question and then we'll go to David with one of the writing, so you don't have to stand up.
Thank you. My name is Asiarania, and before I state my question, I'll just give a brief pertinent background. Last year I went to Europe to do a master's in renewable energy, and it was an interesting master's because it was administered by EUREC, European Renewable Energy Centers, which is a networking entity in Europe which connects different research institutes and renewable energy efficiency across Europe. So my master's constituted a learning in actually 4 different countries. And another part of the program was the fact that it was highly integrated. Components of it were highly integrated with industry, commercial, government people. So I learned from dozens of people, not just from academia, but industry people actually were doing something in industry, came into the classroom to teach. In addition, there was also external company that came in to do like a hands-on wind workshop where you build a 2-meter wind turbine for educational purposes from scratch, which is really interesting. So this master's sort of pointed me in the direction of distributed education, which is essentially what I experienced in the master's. So my question to the panelists, no one in particular, is anyone thinking from a distributed perspective, education in Ontario, leveraging those institutions that have expertise in certain areas, those that have expertise in other areas, or even interprovincially with the United States, etc. I think it's an important thing to think about and appropriate because renewable energy is essentially distributed in terms of the shift.
Shall we go across? You want to start, David?
Sure. That's why what Jose has started at York, I think, is right on the money. As an organization that's been in this for a while, we've basically had pretty much every community college in the GTA come to us looking for information, looking for help, sending instructors. I think there is a critical need for all of those organizations to get together. That's where I was pointing out the issues with training the trainers. Just like there is in the international theater, we need it here as well. And you know, you have some community colleges like St. Lawrence who are definitely out in front. They can't be everywhere and has their strengths. There is a lot of competition between colleges, and I'm not sure what format we get past that. And I'm hoping that that's where Jose's initiative will manage to leapfrog past that, and we can get the community, because you're absolutely right. And then most community colleges already have that connection to industry, so I don't think that's, you know, as in Bab's, you know, presentation, there's industry involved in their research. So we got that part. It's getting that lateral across between colleges and universities. That's something we've really enjoyed watching at Kortright, where, he's gone now. We had someone from Ryerson here, and I've had Ryerson engineering students working with George Brown instrumentation students on the same project. It was done ad hoc so the engineers weren't sure how to hook up instrumentation for the equipment they wanted to measure. And it's just a great thing to see the different, university and college working together, and then colleges working together across the field as well. So Jose, I have great expectations for the organization, and what you're asking for, I think, is what he's trying to pull off.
Charles?
I think that's a great question. I think you are getting me? Okay. It's a great question, and I think it's one of the reasons why, for example, UNESCO, which is specialized in education, launched the solar renewable energy technology implementation. They call upon, for example, UNIDO, which on the industry side, and to come together in the development of this type of program, so that UNIDO will be focused on the industry side, for example, and which, if you mean by industries, it's not only the supplier, it's also the private sector, all those people who are in that area, to come out with a solution on how this system can be implemented. And if you go to the UNESCO and UNIDO training program, wherever workshop they are having, it's compulsory that you have not only people from the education sector, but you also have people from the different sector of education, of industry, for example. That could be supplier, that could be private sector, that could be business people who are also doing the people. And at times they will ask you that we need customer, the people to whom the product is going to be. This might be the very ordinary people, for example. Sometimes they come to a meeting, they never heard of, they just heard of a solar system, and we find for them it's just a dream, because they don't know how it works at all. They heard about it. So I think this kind of initiative is very great. And now the network of trainers which is being developed, for example, initiated at your university, the challenge will be how could we come together to integrate all these different actors in this program here, as you mentioned it, so that we have a very strong initiative. As we always say that most of the people who are against it, they are part of the problem they are part of the problem and also part of the solution. And if we are even able to incorporate all those people also into the program, like the initiative which is being developed at your university, I think that would be a great idea. But the question is, what will be the challenge, and how are we going to be able to implement, to involve even those who are opposed to developing sustainable energy technology?
Thank you. Babs?
Yeah, I just wanted to also mention that St. Lawrence College, we've actually been very proactive, pursuing collaboration with other institutions in the same field. And an example, a success story is our wind technology program. We together with BZE in Germany, developed the curriculum for our wind technology technician program, and that is really going on. And we have them come in to monitor our performance and also give us guidance. We just last week, St. Lawrence College with Queen's University formally signed a memorandum of understanding to work together in programming and applied research. And just last week that was announced. And we're also pursuing, give credit to say, with York University to sign another memorandum of understanding to work together in integrating our programs and apply research. So the college has been really pursuing, a key strategic partnership with other institutions.
Yes, I think I can say almost what I've said before, so I would say it very quickly. I think there are three things from a content point of view first, people have to learn how systems with a high amount of intermittent energy works under different conditions. So it's the system approach is very necessary to how different types of renewable energy plays together with and how this can be developed in a transition from fossil fuel. That's one point. And the second point is to understand how to implement this transition of the whole system, not of single technologies only, but also of the whole system in the right way. And the third thing is, I just mentioned it before, is that this process should be made understandable for people, because it's a big change from stored systems like fossil fuel, where you can just put a match on it, fire to it, and then it burns, to a system that is intermittent. And this whole process has to be understood, and there has to be made simple simulation models that common people can understand. And this has not been done yet. Maybe Red Screen can be a partner in trying to do this. So these 3 points: system approach and how this can be implemented, and there will be a lot of political resistance against it, because and the third thing is to make it very simple so that people can understand what's going on.
Thank you. And my 3 quick comments about this is in regards to the what format part of the equation. You have to avoid competition. Competition actually breeds losers, and collaboration breeds winners. There is a saying in English, there's no I on teamwork. I think that's a very important thing to remember. And Centennial College, which is one of the partners of the Sustainable Energy Initiative, I've discussed this with the president of Centennial College, and there is no competition between our institutions being together. I know that this is, for those of you in the college system, a little bit of a conflictive issue in the Greater Toronto area, but to our fortune, Centennial College and St. Lawrence College are not in the GTA. So we do not compete, we collaborate. Charles actually posed a challenge, which is, how can we keep these things going? And truly, there's only one way to do it. There's a song from the hippie days used to say, with a little help from our friends. And that's how things get done, because Stefan Sanger, that was here in the audience until recently, he has the ability, for example, to help us host the next event of the Train the Trainers in Bonn. We decided to do it in Bonn, Germany, because that's where a lot of the international agencies have their headquarters. And this is a conversation that involves international agencies. But without the help of the organizations like Stefan's and others that are based in Bonn, we cannot simply pull it together. But I think we will be able to do it. And the comment from Babs about BZEE in Husum, that is exactly the direction we all need to move. St. Lawrence College already has the relation with the best place in Germany to do training of wind power technicians. So we need to ensure that we can make that conversation a horizontal and vertical conversation. So people in Kortright can benefit from the knowledge that St. Lawrence has with the people in Husum. And for that purpose, I'll be in Husum on the 24th of November to see what the infrastructure facilities look like, to get a clear idea of what the ask is in terms of resources, etc. Because at the end of the day, the purpose of this panel was to provide ideas to the local decision makers, whether you're in Ontario or in the United States or in Europe. And one specific idea, for example, is that in the budget of the 2012 budget of the Government of Ontario, this is going to be a lean budget, no question about it. You can't keep running deficits, so people will tighten the belt. But there are some specific things that cost very little money and have huge paradigm shifting potential. So, for example, First Nations and community initiatives have been languishing in this province. Even though we have some programs, they are not sufficient. So putting some resources in the 2012 budget to ensure that First Nations and community initiatives can have access to training, it's a good investment. It's actually an investment into the future of Ontario. So this is one of the specific type of items that we need to distill from these conversations to provide some guidance to those that represent us in the legislative assemblies. So we have a question from the floor, but
hello.
We need to go. Sorry, we need to go to a written question that it's waiting as well.
Okay, I just wanted to emphasize the learner's perspective from physically moving around from institution to institution. I just want to emphasize.
Yeah, we believe in learning by doing, all of us in this panel. So I thank you for your question. Could you please read your question, David, that was written, and then we'll go to Dorothy on the floor.
Okay, this question, how much does it cost to build a house that it can exist completely off-grid using renewables? And I think Charles's last slide spoke to that very well, is that there's two sides to it. There's conservation and then there's generation. As much as I'd love teaching a workshop about off-grid home, it's also something that I really don't like, in that if you can be connected to the grid, that is the ecologically responsible place to be. It's also the economically responsible place to be. If I go off-grid, my energy is stored in lead-acid batteries. They are an ecological nightmare. And it costs you $1 a kilowatt hour to cycle energy through a battery. And you're paying 10 cents for it from the grid. If you're connected to the grid, you can use the grid for your storage, so you don't have the ongoing cost and the ecological cost of battery storage. Having said that, the other way of looking at this is, if the question were to be asked to many of the people who would be taking one of the workshops that Charles's ret screen people would be doing, they've got no electricity. How much does one of those systems cost? It could be $1,000 to have lights when there's been no electric light. You go, okay, but you said something bad about batteries. But what are you, in that case, what are you displacing? You are displacing primary batteries that were being thrown away, or you're displacing kerosene. So it's, you know, what are you displacing with this off-grid system? And those are the cost parameters of a very basic 140-watt module, one battery. They were going to have batteries to run their radio and their TV anyways. All you're doing is displacing primary cells that get thrown away with batteries that can be recharged, and yes, they have a life expectancy. So the impact on the environment goes down, their quality of life goes up. Where you take a home that's here, that's connected to the grid, you take a normal house, off-grid, $60,000 for starters. I used to, my income used to come from those customers. They were starting at 30. So the way we always used to do it is, if your connection to the grid is going to cost you over $30,000, it's worth talking to this person on the phone, because they could be potentially be a customer, because they will bear the cost of that kind of system. The other side of this then is, it's a great way when you're off grid, if you do not have your generation and your consumption, if they are not in balance, no matter how big the batteries are, eventually your batteries will end up being dead. So it is a great way of teaching energy conservation, where when we're connected to the grid, it's a little harder to get that across. In my household, 3.2 kilowatts is what I have connected to the grid. Net parity over the year, 0 electrical energy consumption over the year, and no battery storage. So I would say the answer is connect to the grid. You're going to have extra, because when you go off grid, the system might cost $60,000, and the answer really is in the load. You're going to need a very efficient fridge. You're going to need a very efficient heat distribution system in your home. So the cost of all those things go up as well, probably by an equal amount if you are trying to create a normal North American home off-grid. The other option is you can have, and I have lived off-grid very comfortably on a $15,000 system. But there's a thing in the backyard called a clothesline. There is no dryer, there is no hot tub, there is no air conditioning. No.
Thank you very much. David, you didn't say it, but I'll say it. If you want to see a low-income house that is off the grid, go to Kortright. If you want to see a middle-class Canadian home that is a beacon of sustainability, go to Kortright. And if you want to see a commercial-size building of 30,000 square feet, go to Kortright. If you want to see the future, go to Kortright. I have to ask a question now to the audience. We've been asked questions, but this is the only question that I'll pose to the audience. It is 12:00, and I am a man of my word, and I was going to close this panel at 12:00, and I will if you so desire. May I have 5 additional minutes from the audience? Can I have a show of hands? Okay, so the majority rules. One last question, please. Dorothy from OSEA U of T, a great professor.
Thank you, Jose. And Jose comes and speaks in my class all the time, and they just love him, as you can imagine. So my name is Dorothy Golden Rosenberg, and I teach about environmental and ecosystem health to graduate students at the Ontario Institute for Studies in Education, University of Toronto. And I've been involved in these issues for many, many decades. And some of us, I think Paul goes back with me to Amory Lovin's soft energy paths in the 1970s, Canada as a Conserver Society, the Science Council of Canada, during the Trudeau era. And we talked about soft energy paths, and this goes to Fred's talk about the future planning, 50 years hence, where we could have been if we had done that. But we were talking about many of these same issues. The sophistication that I've heard on this panel, and I've learned from Jose over the years, is phenomenal now. But my question is, I guess, one of policy, and how are you all integrating policy for the future? You're doing wonderful technology, you're doing wonderful education, you're doing a lot of inspiring work. But we have a provincial government here in Ontario that's tied around the neck with the nuclear industry, and they have said that when the refurbished reactors come online in a number of years, they're going to cut the grid for renewables. And I think this is a really important issue because the money is not going to be there for the feed-in tariffs and the green energy plan and so on. So I'm wondering what kind of planning, long-term planning, you are teaching with your students in terms of the policy directions that we have to go in.
Thank you, Dorothy. That's a very profound question. And what I suggest, so we stay on the 5-minute limit, each of us will answer your question and provide some concluding comments. Gentlemen, starting by David, we have 45 seconds each. Go.
I've done workshops at Kortright for a very long time on renewables. I've never minded the idea that people would come and learn about solar energy and go home and put no solar panels on their roof. But they would walk away with a new appreciation of what energy is worth and what it costs. So I think negawatts will survive past that time. My passion is renewables, and I hope there's a path forward for that as well. But I think the big thing for Ontario is megawatt generation and understanding how powerful that can be for the province.
Charles?
Well, what I can say from this panel is that for the diffusion and the promotion of renewable energy technology, the barrier really lies in the policy and the institutional framework, because in most cases people are really excited and they really want renewable energy. But the policy, most time policy and barrier are really the main barrier to the promotion and diffusion of sustainable energy technology.
Thank you, Charles.
I'm a very strong believer in policy being the key driver for innovation. A case study, the feed-in tariff program. And in our ESET program at St. Lawrence College, we have a policy component, so students learn, policy and how to, how to, get the right policy in place, to enable the clean energy technologies. And we're also working with the Queen's Institute for Energy and Policy Study and also OSEA's group, depending on them really to help us form a policy framework that will enable renewables.
Thank you, Babs.
Yes, I think there are three things to say. First, you have to make a plan, alternative plan where you say there is a better alternative. In fact, the 100% renewable energy plan we made is cheaper than the fossil fuel plan, which is a reference. And I'm sure you can make a renewable energy plan and a realistic one, which is cheaper than this nuclear plan. And then at the same time as you make this plan, and it could be for 30 years or 35, it requires that it is described in a very simple and clear way.
Thank you very much. And my last comments to you is that the biggest renewable energy resource is the brain. And the biggest obstacle for a better reality is the brain. So now you have seen that we have associated ourselves with each other so we can show to other people that a better world is possible. And I see people every day that are seeing that better world and becoming part of the solution. Stay tuned to our website. It'll be launched November 18th, where we're going to provide specific policy answers to the type of questions that Dorothy and all of you have been posed. I wanted to keep this on time, and I do keep my word. So have a great day. Nice being with you. Thank you.